Hi everyone. Hi, my name is Bastian, and I hope you enjoyed the talks of the XCE Summit so far. Today I will talk about how we broke down a client-side rendered SPA into micro-frontends in a real-life scenario. All of you know single-page applications, basically. All of you are using single-page applications day by day, and I bet every one of you can name at least 5 SPAs when I wake you up at 5 a.m. in the morning. Probably most of you as well developed SPAs in the past or doing it right now. But if you do it right now, maybe stop for 30 minutes at least, right? There will come a point in time when developing an application where you need to reconsider on how to split code, functionalities or sub-applications. For example, will your growing user management section become an own administrative application? Each product has its own story, and I would like to tell you ours. We are the analytics team, a wolf pack of around about 40 people in total, distributed over 4 time zones. The number one question I get asked most when talking about projects, especially in a technical context, is what is your stack, right? So basically, this is it. We use Vue.js as our front-end framework, and we're quite early adopters about 3.5 years ago when we decided to use it in such a scale. Our UI library is based on Vue as well, but it's capable of exporting web components. We are moving to TypeScript now bit by bit, which is pretty eye-opening on certain code pieces, and our backend is in Python using REST APIs. We have a unique challenge as we need to deploy on cloud and on-premise for certain clients, and our infrastructure is done with Docker, K8, and Helm. So without going in too much detail on what exactly a B2B IIoT solution for agile-powered asset management is, and of course you can ask me that later, you most likely can directly spot one of our problems we had at a certain point in time when developing analytics. Maybe a very quick hint. You might say, but actually it's a platform. 20+ applications shouldn't be a big deal. Even if it was planned to become a platform, we started very lean and built an SPA MVP. And yes, we are still running in an SPA at this point in time. And even more, it's client-side rendered. Looking back at it, it feels we have not done anything really wrong. We needed to continuously deliver business value to the platform to fund the further development of it. We did not face issues in terms of performance that did not block each other while running up to 6 development Scrum teams in parallel. The code base was well structured and the overall code quality was also not too bad. We treated our application modules already in a kind of decoupled structure. Some people might say at this point, we have foreseen the scenario and planned accordingly, yada, yada, yada. But no, we just structured the code in a logical and modularized way from the beginning on to be flexible. We utilized code splitting to load code when needed and ignored the overhead. But how do we get all submodules extracted to make them releasable independently and really decoupled? We created ourselves a challenge and gathered requirements in a collaborative manner. This is what we came up with. We want to break down the monster, we want to keep our code quality, we want to share common dependencies, and we actually do not want to rewrite everything. Basically, micro-frontends, right? After a bit of research, I figured out there is not that many possible toolings to create micro-frontends in a client-rendered context. App shells were not ideal, replacer tag variants not sophisticated enough. But what if we just externalize app chunks and load them when needed? Sounds like a plan. Let's investigate on that. I quickly stumbled over Zach Jackson's proposal on integrating module federation in Webpack, and I was hyped until I realized we will not be able to use this. It's way too beta for our use case. And can we find something similar? We found a framework which provided enough for our needs and do not ship a lot of overhead. It's called Single SPA. Basically, it's a routing framework with some fancy add-ons. And you're probably thinking a routing framework alone doesn't do the job, right? Yes. Single SPA recommends the usage of System.js, which is around for quite some time and is an ES module loader. It allows you to import ES modules within the browser context. The main concept of Single SPA is to act as a broker. Shafiq already explained a bit of that already. The orchestrator, as we call it, the root application, will provide the core functionality and is the entry point of our experience. It will declare all applications and registers them. When an application is activated, a single SPA will notify the root application, right? And the respective source will be loaded. This is the point where System.js jumps in, but I will get to that in detail. Usually, you will lazy load applications, right? Which will trigger the Bootstrap lifecycle right before you mount the app. If you do not lazy load applications, and this is somehow which you need to explain me afterwards, the Bootstrap lifecycle will be triggered and the ES module file is loaded into the browser. Mount will be triggered when you activate the app, and unmount obviously when you unmount the app. Utility packages will be used for providing shared instances or packages for all applications from a central point. As you can use as many utilities packages as you like, they can be component libraries as well. Getting a bit context to the registration and activation of an application. You will register an app by specifying a name, right? Which is on top here. The load function will load the application code. We will utilize System.js. The activity functions will determine when an application is ready. A standard here from single SPA is using the location path, but it can be practically any kind of function which returns just a bool. Finally, custom properties over here, which can be handed over to the applications and utilized in the life cycles of your application. So far, so good. But we were thinking about custom releases as well, right? How do I know where to load the module from when it's deployed? Import maps is the answer. Import maps are a draft of the W3C community group, basically a JSON format which is mapping module names to a URI. This allows bare import specifiers to work in a browser context. The fun part is those import maps can be generated dynamically. Small hint on that one, when I was developing on that, they become immutable after you've done the first system import. So please be aware of that. That spent me quite a lot of time to figure out. So just rethink the flow of now, right? The user opens a URL, single SPA activates the related fragment, the entry file mapped to the fragment on an import map gets loaded, and the application will be loaded. Obviously, the application lifecycle starts. So I will give you a quick demo on our root application and our import maps. We have here the index template, which is provided by the root application, right? It's a template which provides two System.js import maps. First one are the vendors, which are available for the whole application scope. And the second one are my micro-frontends. I load here System.js and an AMD loader, but this is just for demo purposes to have this available because I'm not bundling the root application. And here I start loading the style guide and the root config, which then is executing this file. Here we register the applications with the name. We're specifying the mapping for the system import map. And here, as an example, we will load in a reference, a custom prop, which is the XC Summit logo. And we have two applications, a doc dashboard and a rate doc. Let me just switch it. I think we have like this localhost application here, which is the rate docs application, right? So you can see that hopefully now. Please give me a thumbs up if you do. All right, perfect. So on the network panel, when I load the application, you can see it's System.js, named import, style guide, root application, fine, and the two applications which are now here. Actually, one application is the navbar on the left-hand side, and the second one is the rate docs, right? This here is the page header, which is a component fed by the style guide. If I switch the application, you might register here that the URL changes, and this will load the other application. Right, you can see that? Perfect. So far, so good. Let's get back to here to continue. I will get into detail with this further on later. What was the idea again? So let's check. We want to externalize app chunks and load them when needed. Actually, done, right? We can load them when we need them, and we have externalized them. So basically, we now have a rough idea how to create the apps independently and load them when needed. So let's see how we can utilize this in our specific use case in analytics. So we came up with the following. As we have a platform where each user might have different rights to applications or modules, we need an application service registry which provides a list of accessible applications in the user context and the respective import maps based on their permissions. A portal frame will render the base layout like header, navigation, and it's obviously always active regardless of the route, right? Our design system is loaded next to the portal frame and made available for all other applications, including the portal frame. This is very important because you can really end up in race conditions on those kind of things. A few of you will miss a central store here, and Rafiq, I want to talk to you after my session because I have a completely different opinion, because one does not simply share state across micro-frontends, right? Really, don't. The simple answer is actually decoupling. A micro-frontend should work in itself. It relies to another state or even micro-frontend. Congratulations, you have introduced coupling again, right? Didn't you want to get rid of that in the first place? The possible solutions are here, for example, from my point of view, you can handle state on the server side, decoupled from your actual state management mechanism in the front end. This will allow you to switch between frameworks at any time, like you can do Vuex, or you can even do React with MobX, greetings to Pavan, right? Or which can be any kind of type of framework, right? What we used is a JavaScript event hub, a pub sub with namespaced event. It's simple, it's performant, and it works. It should be mentioned that we just have a very few states that we share across the micro-frontends. Actually, selected language, login, yes or no, and errors are the only ones which I can just think of, right? Remember how we structured modules? If you're familiar with Vue.js, you're probably aware that any component could be a Vue.js app in itself. So what could happen if we just move all the code of an existing module in a blank Vue.js application wrapper, right? We just need to update some core references to our new utility packages and provide a new entry file, which will comfort the new single SPA framework. Basically, as you can see that here, it just has a few parts. First of all, I need to set a name, right? The public path. And marking that for the system.js module import. And helper to enrich our Vue instance with the single SPA lifecycles, which is done here, is also needed, right? There are already quite a few helpers existing provided by the single SPA community. And just to name a few, it's done for React, Angular, Svelte, Cycle, Ember, Preact, Inferno, Riot, Backbone, Dojo, Alpine, HTML web components, and I think I got them all, but probably a few more. And finally, the single SPA lifecycle callbacks, which you find down here. Our actual application code is completely the same. We are using Webpack as well to build our code, and we used it before, and there was no need to change this. I think you can use rollup and parcel as well. There are just a few tweaks you need to take care of beside of your usual Webpack config. We need to add a JSONP function name to have unique chunk namespaces to reduce colliding chunks, right? To reduce the load of your application vendors, you can just externalize packages from your build, which will be needed, which will be feeded, actually, sorry, and utilized via the new browser system.js context globally. You might recognize the regex pattern on that one. We have decided on a scope naming convention, so our code in-browser modules, for example, the core API piece or root application and portal frame have those, that we are not importing them or bundling them or try to bundle them in our Webpack build, so we can reference it. Finally, how do we deploy it? Without going into too much detail on the K8 cluster setup and so on, it's quite simple. We have a Webpack build and the Docker ships it. We have a simple Nginx running with static files, that's it. So now I try again the demo. I hope this will back. Now it works, awesome. So now going a bit into detail of the application. So we have two applications, the rate docs application and the docs dashboard, right? Absolutely straightforward Vue CLI standard applications. We have a component here, which is rate docs. fetching a random dog, setting a default rating to 1, and then you can rate that, store that to the local storage, which is then in our scenario a state to share a state across our micro front ends. We push that and set a new dog. Done, right? The app looks also like a standard application, right? The main file is the adjusted one, and here the set public path is just extracted. The same on the docs dashboard, absolutely the same. A small router, which is providing the path of it, components, done, just fetching here the local storage. So, but now the interesting parts come into place. We have a style guide which shares a component, which is the page header, right? And we introduce that in here as well, right? So we do an import page header from add view mf style guide, which then will be loaded from this chunked library, right? Whoops, sorry. Here it's, well, I scrolled that too far. This one here, it's just exported very, very simple. The main benefit of externalizing, for example, a component library is, right? Think about that application here. Ah, damn, this is again here. So it's dark blue or gray, define it like you want. And so I want to go yellow with this, right? Now it's yellow. And it's not only yellow in one application, it's yellow in both applications. So you can quickly adapt a new style to your whole ecosystem by manipulating your UI framework. Or, which is even better, if you just have CSS injected, you can do that as well for here. Nah, come on. Where is it? I hate full screen, sorry. You have a pink background. On the left-hand side, this is just gray because the navbar is marked as gray. So far, so good. We have now a rough idea how to do it, as we require all teams to adjust as well code in their modules, which they own. We need to have a solid plan to reduce the time frame of our needed feature freeze, right? Because we need to rip everything apart. We need to stop developing on all applications in parallel and to then roll out this kind of new architecture and restructure our application code, right? So we decided to do a prototyping phase with our core team to really get familiar with the technology and revalidate the possible undocumented issues or edge cases which we have gotten thought through. Quite fun fact at the side, when exact the same day when we wanted to start our prototyping phase, the lockdown in Germany for COVID started. So we have completely redo our planning as we were doing actually a planned workshop all together from the UK and Germany here in the Cologne office, which was not possible anymore. The prototyping phase shaped the exact specification of our new core framework. It was very, very helpful to get everyone on the team familiar with the concept and the framework. The target was to reduce the feature freeze to an absolute minimum. We questioned ourselves on how to accelerate the teams as well on migrating their application. As only some quite generic code changes were actually needed, and those were very repetitive, we required to add some kind of a generator to make available for the teams, right? We utilized Yeoman for that, which most of you probably know. We built a generator which bootstraps a blank application with all required configurations, right? Which allowed the teams to basically copy and paste their code into it. As all new applications were required to be deployed and independently and provided with a standard pipeline, right? Which was also pre-configured by the generator. This allowed the teams to set up their pipelines within 2 clicks and deploy it right away. The pipeline config was centralized in a repository, so everyone is using the same quality gate, the same pipeline, and is not able to bypass quality checks and cheat on that. Obviously, not everything is working as perfect as it sounds today. We had a lot of learnings. First of all, do naming conventions. You can only run such a system with automated and standardized functionalities which rely on naming patterns and namespacings which are centrally distributed to the teams. There will be edge case scenarios, regardless on how detailed your plan was. Be prepared for it. It may be a bug in a framework, a new release of dependency which does not work along in conjunction with your existing ecosystem, and so on and so on and so on. Micro-frontends are multiplying the complexity of an application dramatically. All team members need to have a rough understanding how to test actually a UAT version of an application where each fragment becomes a variable in itself. You need to have a solid DevOps team to handle the increased amount of repositories, pipelines, and so on. If you have the ability to explore and try out your plan with the team, it will increase the code quality massively, and the speed, obviously, on the execution later. Last but not least, theoretically, you can implement something like that without a big bang, right? This would take a bit more time and lead to more technical debt maybe on the small fragments, but it is definitely an option. We were just lucky to be able to do that at once. To sum it down, right? The average migration of a module was 2 days in average. And one of the biggest outcomes was, beside of the fact that we could now release independently, is we reduced the initial load in average of an application from 60K down to 14K, which is massive. Thank you. And as well, there's another micro-frontend talk, which I would like to reference to, which is Matthias. Have a look at how he provides, how enables the DBT, by using micro-frontends. All right, thank you.